Hello. So in this video, we're going to cover week 2 lecture about atoms and the periodic table. So the first thing that we want to know for this lesson is going to be something called the atomic theory. So the atomic theory is the scientific idea that all matter, so all things, is made up of tiny indivisible particles called atoms. This concept developed over centuries as scientists discovered more about the structure of matter, but we're going to cover the structure of atoms further in this video. So just know that every single little thing, every single thing that we have in our world, animals, rocks, like a pillow, all these things are composed of little tiny particles that we cannot see called atoms. So we're going to learn the structure of atoms in this slide. So the structure of an atom is that it consists of a proton, a neutron, and an electron. So a proton is going to be in the atom we have a nucleus. So this is going to be the nucleus, and then we have electrons around it. So in the nucleus, we have protons, which have a positive charge, and then we have electrons, and then we have neutrons with a negative neutral charge. So to memorize this, just remember that neutron sounds kind of like neutral, so it doesn't have any charge. And then around it, we have all sorts of different electrons in different placements. So now we're going to go over a little bit more about the properties of these subparticles, and then their identities. So a proton is going to be positive. It's going to be classified as a cation, and then electron is going to be negative. It's going to be classified as an anion. And then in a neutral atom, you want to know that the number of positive charges must be equal to the number of negative charges. Sorry, my voice is going away. And then so if we have a neutral atom carbon or something like that, the number of protons is going to be equal to the number of electrons. So this brings us to isotopes. So what if we have the same number of protons, which protons determine the identity of a molecule? One proton is always forever going to be hydrogen. 2 protons is always forever going to be helium. It can never be anything else. But what if the number of neutrons changes, therefore changing its mass number? Because the mass number equals the number of protons plus the number of neutrons, and then this equals the mass number. So what if that happens? What if the number of neutrons differ? So when the number of neutrons differ, it is going to be called an isotope. And isotopes, by definition, are atoms of the same element. So element meaning it has the same amount of protons, but have different number of neutrons. So we're going to do some practice just to review this and just to bring it all together. So isotopes, it can be something like carbon C13. So if you look over here, we look for carbon. We know that carbon usually has a mass number of 12.01, 011. That's just because usually a carbon has 6 protons, and then it also has just 6 neutrons with it, just to make it complete and just neutral and just like it's usually how it usually is. But sometimes it might have an extra neutron. And how we know this is because of the formula. Protons plus neutrons gives us the mass number. This is the mass number represented right over here. So if we were to do something like 13 minus the number of protons we know for carbon is going to be 6, it gives us 7, meaning we have another neutron over here. So we have an extra neutron for this carbon molecule. So it's going to have 7 neutrons. And then the question asks us how many protons, electrons, neutrons does the following isotopes contain? So we know that it has 6 protons. It has 7 neutrons. How many electrons does it have? So if we look at this molecule right over here, we can see that there's nothing to tell us that it's positive or negative or anything like that. So we're going to assume that it's going to be neutral. And in a neutral atom, the amount of protons tell us the amount of electrons, because they have to have equal amounts of each other in order to be neutral. So it's going to be 6 electrons. So now we answered our question. This molecule has 7 neutrons, 6 electrons, and it has 6 protons. So if you want, you can now pause this video and you can just do fluorine, and you can do nitrogen as well. Okay, so now that you came back from that, and we're going to do fluorine and we're going to do nitrogen for practice. So we have our molecule fluorine right over here. We know that it has 18. It has a mass number of 18. We know that mass number is going to be equal to protons plus neutrons. So in order to answer our question, the number of protons, the number of electrons, and the neutrons, first we know that fluorine in general, since the amount of protons for an element will never change, because if it changes, it's going to be a different element. We know that fluorine is going to have 9 protons every single time. And since it's a neutral atom, we know that it's automatically going to have 9 electrons. The only thing left for us to figure out is going to be how many neutrons does this isotope have of fluorine. So using this equation, mass number equals the number of protons and the number of neutrons. And just in case I haven't mentioned it, the reason why we don't include electrons in the calculation of our mass number is because electrons are so tiny, so small, that it doesn't really make a big difference if we include them or not. Like they weigh literally like almost next to nothing. So we just focus on protons and neutrons, which is where most of the atoms' weights come from. So in order to figure that out, we know that the mass number is going to be 13 equals the number of protons, 9p, and then plus, we don't know the number of neutrons. So we can do minus 9. So that gives us, that gives us 4. And then we have a total of 4 neutrons for this, which gives us our final answer, which is this isotope of fluorine is going to be 9 protons, 9 electrons, 4 neutrons. And now we're going to do for nitrogen real quick. So nitrogen, we have a mass. So we're going to look over here. The number of protons of nitrogen is going to be 7. And then it has a mass number of 15. So it's neutral, so we know that it has 7 electrons. So we're now looking for the amount of neutrons. So in order to figure that out, we have 7 protons, 7 electrons. Okay, so we know this equation. The mass number equals the number of protons plus the number of neutrons. So we're going to basically come over here and go 15 equals 7 plus number of neutrons. Since we don't know number of neutrons, we can just do 15 minus 7 minus 7. And that will give us 8 neutrons. So now we have the final answer for this 8 neutrons. So if you know how to do isotopes practice and you did good on this, you are okay. You'll be okay. If you don't, it's okay as well. You will also be okay. Just let me know if you have any questions by email or text message or anything like that. And then the next thing is going to be a summary of periodic trends. So the periodic trends is just going to tell you how like certain things are as you move around a periodic table. For example, atomic radius, which is going to be the atom size, distance from nucleus to edge. The trend is as you go from left to right. So as you go from left to right, the atom's radius gets smaller. And then as you go down from top to bottom, the atom's radius gets bigger. And then the ionization energy. So ionization energy is the energy required to remove the outermost electrons. So the outermost electrons are going to be our valence electrons. So we have something like carbon, which has 6 valence. Actually, carbon has 4 valence electrons around it. So it's going to be C, 1, 2, 3, 4. The amount of energy to remove these outermost electrons is going to be called our ionization energy. And the trend on a periodic table is as you move to the right, your ionization energy increases, and then as you move down, your ionization energy decreases. So they're going to be the opposite of atomic radius, but it's going to be the same trend for electronegativity, which electronegativity is an atom's ability to attract pull electrons in a bond. So it's how much an atom wants that electron. So the closer it is to fulfilling its octet rule on its valence shell, meaning the closer it is to having 8 electrons around it and becoming like fulfilled in life and everything like that, which is like the ultimate goal for atoms, the more it wants those electrons, meaning it has more electronegativity. So as you go from left to right, the electronegativity increases. As you go from top to bottom, the electronegativity decreases. So as you do your homework, just consult with this for any help or any to solve any of those questions. And then lastly, we're going to learn about electronic configuration, which just is a way to basically represent how electrons are in an atom, or they're arranged in an atom. The first thing that we want to know, and this is just going to be like some background information, is going to be electrons move in a wave-like motion. So because they move in a wave-like motion, we can use the wave equation in order to calculate where electrons are going to be in a given atom. Once we calculate this, we have certain places where the electrons are going to be most likely found. So these certain places are going to be called orbitals. And in each orbital is going to be 2 electrons. Each moving in a certain direction. So it's going to be either up and down, or just like they're going to be moving in opposite directions. That's all you really have to know. So once we know this, we're going to learn about energy levels and the shells. So each atom has a certain amount of energy levels. So if we have one energy level, it's only going to have one shell. Usually it's going to be the S shell. And the S shell contains 2 electrons. when we go and move on, following this line, we go to the next energy level, which is going to be 2. And the second energy level has an S and a P shell. So the first S shell always has 2 electrons, and then from there, the second shell, P shell, on the second energy level is always going to have 6 electrons. But if we were to look at this more closely, this will be 1 orbital. Each orbital can contain 2 electrons, so it's going to be 2 electrons. And then this will be 3 orbitals. Each orbital contains 2 electrons, which will be a total of 6 electrons on the p shell. So we learned this. And a visual representation, I'm just going to show you guys how this will look in like an actual atom, just in case you need more clarification. If you don't, you can always just like skip this part. So like we said, for the arrangement of electrons around a given atom, it first starts with the S shell. The S shell is always going to have the shape of a spear. And then this S shell, following the rule that electrons move like waves, you can find the electrons anywhere around here. So it's going to be like this. But there's only 2 electrons around here, but they can be found anywhere over here. And the places that they're most likely to be found are going to be called orbitals. So let's just say it's going to be here and here. That represents our first shell, which has 2 electrons, and that's going to be our first energy level. Then we're going to go to our second energy level, which is going to consist of another S shell. But this time it's also going to include a P shell. A P shell. So if we were to look at this, for the first one, it's going to first fill the S, like following this line of electron configuration, which is going to go 1s first gets filled and then followed by 2s. It's first going to fulfill the on the second energy level, it's going to fulfill the second S shell first. So over here, so 2 electrons, that basically means that 2 electrons have to be in the second shell before, the second S shell before they go to the P shell. So 2 electrons, and then followed by, over here we have a p orbital, and then it's going to be a total of 6 electrons. 6 electrons can potentially be found over here in this entire place. So you don't really have to completely understand this, but just kind of get the idea of this. If you have the idea, we're going to go ahead and move on to electronic configuration. So electronic configuration, like we said, is going to be a representation of how electrons are in a given atom. So for our example here, we have fluorine. So fluorine has how many electrons in total? So in order to figure that out, let's just go ahead and go to our periodic table and look for fluorine. Fluorine has a total of 9 protons. Since this fluorine, it didn't really specify if it was neutral or not, we're going to assume that it's going to be neutral because it doesn't really specify if it has a positive or a negative charge. Positive being cation, negative being anion. So we're going to have 9 protons, which means that it has 9 electrons. If we were to refer to like our isotopes and everything like that and what we learned, we know that it has 9 We don't actually know that because it doesn't really give us the mass number, but let's just go ahead and go to electronic configuration. So 9 electrons. So we're going to try to represent 9 electrons in this electronic configuration for fluorine. So we first start off with our first one. Our first one is going to be 1s. So we're going to say 1s, and how many electrons can be held in the s shell? It's going to be 2 electrons. And then we're going to go to 2s, following this line right over here. And then how many electrons can be held in the s electron shell is going to be 2. So now we have, looking at the amount of electrons that we need to write, we have 9 electrons, and we already wrote 4. So we have 5 electrons left to write. So we're going to go to the next one, and that's going to be P, following this line. So the number of P is going to be 2P. We're going to write 5. So the P shell can hold 6 electrons, but we wrote 5 because we only have 5 more electrons to designate for the P shell for fluorine. So this will represent the electron configuration for fluorine. But for every single electron that you have, if it has the same number of a noble gas, so these are our noble gases, they're going to be on group 18. So it's going to be something like helium, neon, argon, and all of these. So these are going to be our noble gases. So if you have 2 electrons, and you look at our noble gases, that's going to be helium. So we can always just like simplify our electronic configuration by just replacing the number of electrons with with one of our noble gases. So this is going to be like something like helium, which represents 2 electrons. So we can just replace it with 1s2, but we're still going to continue with 2s2 and 2p5, representing our electronic configuration. So if you don't understand this part, where we can replace one of our noble gases with the specific number of electrons that it represents, you're going to be clarified with this once we start doing practice. So we already have our answers right over here, but just go ahead and ignore it for now, because we're going to go ahead and practice and do it by ourselves. So I'm going to go ahead and get a sticker. Just ignore this part. And we're going to practice. So for chlorine, first we want to find out the number of electrons a certain atom has. So if we look for chlorine over here, we see that it has, so the top number always represents the number of protons. So it has 17 protons, and since this is a neutral atom, we can conclude that it has 17 electrons because of that. So we're going to write it as 17 electrons, 17 protons, because it's neutral. And then we're going to try to represent this in an electronic configuration. So it's going to be 1s, one s2, 2s2, it's going to be 2p6, and then from there we have next 3s2, and this is going to represent 2, 4, 10, 12, so we still have 5 more electrons to represent. So after 3s, what do we go to? Following this line, it goes to 3p. So we said that we had 5 more to go, so we can just write 5 for this. And that's how to represent it in electronic configuration. But if we were to look at this, it has a total of 17 electrons. So one of the noble gases does have 10 electrons in total. And that's going to be neon. And then we're not going to use this one because it's 18 electrons. That's not like the that's too many electrons for chlorine, so we're going to go to neon. So to represent and simplify our answer, we can just write neon, and then we can write 3s2 and then 3p5. So if we were to look over here at our answer, that is the same answer. So we got that one correct. And then if you want, just to test your understanding, you are more than welcome to pause the video and just go over copper and how to do that one. And then now we're going to work on it together. So we know that copper has a total of 29 protons, meaning that it has a total of 29 electrons. And we want to represent that in electronic configuration. So it's going to be 1s2, 1s2, and then it's going to be 2s2, and then it's going to be 2p6, 3s2, 3p6. That's going to be a total of 18. But we still have like a lot more to go. So 29 minus 18. We still have 11 more electrons to represent. So after we do 3p6, following this line, we did 3s, 3p. The next thing is going to be 4s, which electron shell only, the s electronic shell only holds 2. And then we're going to go ahead and move on to our next one, 4s, and it's going to be 3d. So 3D can hold a total of, if we go back to our slide, it's going to hold a total of 10 electrons. But how many electrons are we missing for this one? So we already have 4, 10, we have 12, we have 18, and we have 20. So we only need to represent 9 more. So even though the D shell can hold a total of 10, we're only going to write 9 because that's the total amount. So this brings us to our answer: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9 for our copper. So from here, we looked at this, and like for you guys who anyone who understood the noble gases and the replacement, and like you just know the noble gases from your brain, you might be thinking, you know what, this represents 10, but if we look at it closer, doesn't this entire thing just represent like 18, which is one of the noble gases? So like 2, 4, 10, 18, one of the noble gases. And the answer is yeah. So we come over here to one of our noble gases, and the noble gases as for 18 is going to be argon. Let me just make sure. Yep, argon. So it's going to be argon. So we can just replace this entire thing. So right over here, we can replace this entire thing right over here, which is 18 electrons, with just AR. And then we can continue with 4s2 and 3d9. So it's going to be 4s2, 3d9. And that's going to be our final answer. So let's go ahead and double check with our answer over here and see if that's correct. Okay, we got this part correct. And we got this part correct. So that's all that you have to know for week 2. I hope this was a good lesson. If you guys have any questions or anything like that, please let me know. So we learned electronic configuration. We learned the isotopes. We learned about the properties and identities, subatomic particles, and that covers everything for atomic theory, which is going to be like everything about chemistry. You guys have a good day.